Okay, so what I want to do is determine the exact values of these cosecant inverse and secant inverse problems. By the way, arcsec, that's the same thing as secant inverse. Arctan, same thing as tan inverse. Cos inverse, all that kind of stuff. I don't know why I don't actually know where arcsec comes from. But anyway, uh, so when we're doing these inverse trig ones, you have to remember what the ranges of them are. So sine inverse, if you do sine inverse of something, it's going to spit back an angle that has to be between negative pi over 2 and pi over 2. I don't know if you remember this, but we talked about it briefly in class. So this is the range for sine inverse. It's also the range for tan inverse. And since it's the range for sine inverse, it's going to be the range for 1 over sine inverse too. It's going to be related to that. The other three go from 0 to pi. So the other three are going to be cosine inverse, cotan inverse, and secant inverse. So now we've got our ranges, so that can help us figure out which answers we need. So if we look at A for 16, it's cosecant inverse of negative 2. All right, so one way of thinking about that, if I wanted to call this like x, then that's saying the same thing. Or actually, it's an angle that we're solving for, so I'll call it theta. So that's the same thing as saying cosecant of theta should be negative 2 if we're only looking at all the thetas that are between negative pi over 2 and pi over 2 only, no other thetas. So cosecant is defined as r over, which one? R over sine, so y. Um, so in a unit circle, we get negative 2 as r over y. R is always positive. Y is going to have to be the negative thing, so it's going to be quadrants 3 or 4, except that I never get to use quadrant 3 when I'm using inverse trig. So this is going to have to be down here. This will be the negative 2. Or actually, sorry. Let's make this negative 1 and the radius 2, so it's like negative 2 over 1 there. So this triangle right here is actually a 30, 60, 90 triangle where this is 30 degrees. If you calculated this side, it'd be root 3. So we've got negative 30 degrees right here. You might think it's 330 degrees, but it's not, because that's not between negative 90 degrees and 90 degrees. Remember, we're stuck in that range. So negative 30 or negative pi over 6 radians, whichever one you wanted to use. So I'll put that up here, negative 30 degrees or negative pi over 6. The next one is cosecant inverse of root 2. So that's the same thing as saying when is cosecant root 2 equal to root 2. And so we can think of root 2 as the r over y again. It's got to be then be in, since y has got to be positive, it's got to be in one of these two quadrants, but cosecant inverse has to be in between negative 90 and 90. So we're not going to look over here. We're going to look at this area. And since it's positive, it'll be quadrant 1. It's the y. It's the r over y, so I'm going to make this the r and this the y. And so this ends up being a 45, 45, 90 triangle. So this angle here is 45 degrees or pi over 4 radians. Okay. The last one here, cosecant inverse of this. So this we can evaluate just using regular trig. So 2 pi over 3 is right here at 120 degrees, which means I've got 60 more degrees to work with in a 1 root 3. Oh, whoop. That's the 60. Root 3 goes there. 1 goes here. 2 goes there. And so secant is it's r over x. So secant of 2 pi over 3 is secant of this angle. R over x is going to be 2 over 1. So this whole thing turns into cosecant inverse of this which ends up being 2 over 1. Well, we've already done this. That's part A. So it's got the same answer as part A does. Okay, so let's look at 17. So I'm just going to move down here and rewrite 17. So 17 says find arcseek, which is secant inverse of -1 for A. And let's see, what did B say? B said find cosecant secant inverse of -√2. So cosecant secant inverse of -√2. All right, we'll see what happens. Okay, so secant inverse of -1. Well, that's saying for theta, when do I get -1 for my answer, right? And since it's related to cosine inverse, we're only allowed to be in one of these two quadrants between 0 and pi radians. So secant is the same thing as r over x. Well, r's got to be positive, so x has to be the negative thing. And the only time this is going to happen is if it's over 1. So I'll make the r +1 and the x -1. So if we graph this out, the only time that happens on the unit circle, when I get the r being 1 and the x being -1, is right here on the x-axis at pi radians. So this answer has to be pi. It can't be -pi, it can't be 3 pi, because that's not in the the secant inverse range. It's got to be between 0 and pi inclusive. Actually, it turns out it can't be this one, but we'll get to that later. Okay, so the last one, secant inverse of -√2. Okay, so let's see. Secant inverse of -√2 means... Now, remember over here, we already played with secant inverse. It's got to be in the top half. And if it's a negative, and secant is defined as r over x, then I'm going to make the r √2 and the x -1. So here's √2, here's my -1 in that direction. So this is a 45-degree angle here, which means the rest of it is 135 degrees. So right here, I'm at 135 degrees, or 3 pi over 4 radians. So it's 135 degrees, or 3 pi over 4 radians. And then I got to take the cosecant of that. Right? So it's the cosecant of 135, or 3 pi over 4, however you want to think about it. So, well, the cosecant is defined as the y over the r. No, sorry, r over y. And really all you need to do is then figure out what this is, and that's going to be a 1 right there if you do Pythag. It's a 1, 1, √2 triangle. So if I set this up to be r over y, yeah, that's right, r over y, then this is going to end up being √2 over +1. So it's just √2 is your answer. Okay, I hope that helps.